0, -4. A, determine the coordinates of A, sorry, that's supposed to say of A, third point on the parabola. And B, it's asking, does the parabola open up or down based on your findings? All right. So whenever you're given a question like this to find another point, or in this case, a third point on the parabola, your best bet, right, is to use, yes, keystrokes are always required whenever any assessment. If you use your calculator to find a point on the line, we put down the keystrokes. Yes. Yeah. Okay. So whenever you have something like this, vertex gives you the axis of symmetry, and you know another x value technically, right? The y-intercept is 0. So finding a third point, you should resort to this formula every time. Okay? That's the one you want to be using when you are in a situation like this. Okay? So for A, right, the vertex gives us the axis of symmetry, which is x is equal to 4. Okay? We also know the x value of another point I'm going to call that x1 is equal to 0. Okay? Use x is equal to x1 plus x2 divided by 2, right, to find third point. Okay, so we're going to substitute in. X is always this is the axis of symmetry, which is given to us by the vertex. Okay, so we know that this is 4, and x1 in this case I chose it to be 0. I don't know x2, and I've substituted in whatever I could. I multiply both sides by 2, canceling this here. So you end up with 8 is equal to 0 plus x2, and that is easy, right? x2 is just 8. You haven't found the point yet. A third point is 8, right? And remember that the point, like these two x values, right? These 2 points that you grab the x values from have to be at the same height. So what is the height of that, of x1? It was -4, right? It happened to be -4. So there it is. So you just found the third point. So if we were to graph this, just a sketch, this is not a graph, right? Not a nice graph, right? X and Y, right? Approximately at 0, -4, this is the y-intercept mentioned, okay? 4, 7, right? This would be 4, 7, somewhere way up here. That's the vertex. And so we knew that this parabola will go through it like this, right? This being the y-intercept. And so the other leg is going to go exactly folded, right? It's going to be symmetrical to this side. It's essentially folded along the axis of symmetry. So if this is our axis of symmetry here, right? This is the AOS, which is x is equal to 4. Okay. So what we have found is the point that's going to be across, I call this the cousin, right? This is a point and its cousin is right across on the other side, right? And so this is the point we just found, which is 8, -4. Right? So you're using that this symmetry of the parabola to come up with that point. This can also just be done visually. Like if you're looking at a parabola, let's go up a bit, right? Think about it. From the y-intercept to this stretch right here, how many units are there in between? Like from here to here, we know it's 4, right? So if this is 4, then we know that from the axis of symmetry, if you continue to the other leg, we know that this also has to be 4. So 4 and 4, right? Your x value is 8 to get to here. Does that make sense? And it's always going to be the case. If this had been 3, the vertex had been like 3, 7, then it would have been 3 here and another 3 to get to the other side, which is 6, right? So you're basically doubling. If you double the vertex x value, you get this point that is across from the original -4, right? It does not work if you have one point here and one down here. You can't do it, right? It has to be straight across, okay? And so that's a very, very important principle to get that. So the answer is it points down, right? B points down. We could have predicted that without finding that third point, by the way, because if you know your vertex is there and this is your y-intercept, right? You know that there has to be another one going this way. Okay, so we could have predicted that without finding A first. And I wanted to use the graphs you did, like that you worked on for homework, to do the same thing on here on the last one. So it'd be question 4 on page 4, just to show you how useful this is. So we're almost going back to an example we've already done to apply something we've learned just now. Okay. I am hoping you're done, folks at home. I have a very hard time timing it, but I'm just looking at folks here and they seem to be done. So if we were to go to question 4 on page 4, okay, we knew that this is our parabola here, in this case it's pointing up. We know that the y-intercept right here is 0, negative 225, right? We knew that point. We also knew the vertex, right? The vertex, I'm just going to tell you what it is. It's negative 6, negative 405. Don't worry about the y value, right? You're looking at 6, right? So if this is where the axis of symmetry is going to go through, like this, right? So what you've just discovered is that from here to here, it's going to be 6 units. And to go from here over to the other side, to this leg of the parabola, it's going to be another 6. It's a distance, right? So what is going to be the coordinate of this point on this side? I know that the y value will be the same. And what is this going to be? Negative 12, right? Because you went 6 this way. That gets you to negative 6. If you go another 6, that is negative 12. So you found the third point just by looking at the parabola. You use the y-intercept, you flip it over, you get it, right? But you could have done the same thing using this one, right? You could have, right? What's the value of the axis of symmetry? It's negative 6. So you could have plugged in a negative 6 there. You could have plugged in a 0 here because you knew that point, right? The x value of the first point, and then found that second point. And I can guarantee you, you would have had a negative 12. I'm just going to go dot, dot, dot. So you can do it visually or using the formula. If I were given a graph, I wouldn't use the formula necessarily. I would just come up with that, and that's fine. But a pattern that I will tell you is that you can always just double the x value of the vertex to get the x value of that point that's across from this side, right? And you'll see me do a bunch of examples as we move forward. Okay, all right. Let's do, it's 3 o'clock, so I'm gonna start word problems here. That's what applied is really all about, a lot of word problems.